Welcome to my YouTube channel, and today we'll be looking at ordinary differential equations, and let's have our discussion. So ordinary differential equations, when that word comes to your mind, you may think of an advanced differentiation. You may think of an advanced differentiation, or in other words, all levels differentiation, but it is something that is not far away from that. So it has a very close relationship to the differentiation that you already know. So in mathematics, a differential equation is an equation that contains one or more function with its derivatives. The differential function, the derivative of a function, is you can say it is the rate of change of a function at a point, and it is mainly used in fields such as physics, engineering, biology, space, and so on. Then the primary purpose of a differential equation is the study of solutions that satisfies the equation and the properties associated with that solution. And the easiest way of solving a differential equation is by use of explicit formulas, and we have some different methods of how to solve a differential equation. And before we go to the different methods, let's first understand what it simply means by a differential equation, what it means by having a differential equation. So we have said that a differential equation is one that contains one or more terms, and allow me to use the word variables, one or more variables, and the derivatives of one variable, e.g. it can be the dependent variable with respect to the other independent variable, with respect to the other independent variable. For example, when you talk of d of y over d of x being equals to f of x, we simply imply that here x is an independent variable, and y this is the dependent, y is the dependent variable. Now, a differential equation contains derivatives which are either partial derivatives or ordinary derivatives. So it contains derivatives which are either partial derivatives or ordinary derivatives. So they are either partial or ordinary derivatives. Now these derivatives represents the derivative represents the rate of change. It represents the rate of change, and the differential equation describes a relationship. This one describes a relationship between the quantity that is continuous, or continuously varying with respect to the change, in another quantity. So you can simply say that the derivative represents the rate of change. It represents the rate of change, and the differential equation describes the relationship between the quantity that is continuously varying with respect to the change in another quantity. That is very important to note. It is very important. So when we narrow down now to the order, of a differential equation, that is order of differential equation, So you can simply say that the order of any differential equation, this is simply the order of the highest order derivative, present in the equation. For example, we can talk of example number 1. You can say dy over dx is equals to 3x plus 2. So you can simply say that in this equation we have equation, this is in order, this is first order This is first order differential equation. Then we can say example 2, we can have second derivative of y with respect to second derivative of x being equals to 4 dy over dx plus 4y is equivalent to the exponential of 2x. So we can say that this is second order differential equation. So why is it second order? Because the power of the highest derivative is 2, so that's why it's a second order differential equation. Again, we can have it in this form, that into bracket dy with respect to x to the power of 4 plus 5 dy over dx equals to 65x. So you can see that this is first order, that is first order, that is first order fourth degree differential equation. Then we can have another one in this form, that derivative with respect to y with respect to that derivative of x plus 6 dy over dx plus 6y equals to 0. So we can simply say that this is third order, that is third order first degree, third order first degree differential equation. So you can simply say the degree of a differential equation is that of the highest power of the highest differential which the equation contains after simplification. Let me repeat that the degree of a differential equation is that of the highest power of the highest differential equation which the equation takes or contains after simplification. So for the example, we can say just an example, e.g. if we have an equation that is second derivative of x with respect to second derivative of t, then everything raised to power 3 plus 2 dx over dt, again everything raised to 5 equals to 7. So the 3 here represents the degree. This represents the degree of the equation. It represents the degree of the equation, while the power inside here represents the order of the equation. It represents the order of the equation. So therefore we can say that our equation is second order. This is second order third degree differential equation, second order third degree differential equation. So differential equation are simplified by solving or by simplifying the differential equation itself. A solution to a differential equation which contains one or more arbitrary constant of integration is called a general solution differential equation. And before we go to that, first let's look at types of differential equations. So number one, we have the ordinary differential equations. And under these ordinary differential equations, they mostly include separation of variables, differential equation. Then we have equation that contains an integrating factor. Then two, we have the partial differential equation. Then we have the linear differential equations. Then number four, we have non-linear differential equations. Then five, we have homogeneous differential equations. Then number six, we have non-homogeneous differential equations. So with that said, in this topic we will simply look at the following. We will investigate solutions. Of differential equations, and to be specific, we look at first order separation of variables. Then we look at first order homogeneous differential equations. Then we look at first order linear differential equations. Then we look at second order, and here we'll use the method of determination of coefficients. As our solving method. Then we look at solutions solutions to second order differential equations. Then we will investigate something on the D operator method, and in this D operator we'll have a simultaneous differential equations. Then there will be the series method. Then we'll look at in a few, that is the application of differential equations, and this one is in application is mostly found in control engineering systems, and this one will help you in the subject we refer to as control systems for engineers. So the subject is control systems for engineers. So if you are an engineering student, this one is for you. Then we look at resistor, inductor, capacitor circuits. Again, this is specifically for someone doing a subject in electrical and electronics engineering. This is very important to have some basic knowledge there. So first, let's begin by solution. This is begin by solution of differential equations using separation of variables. So under this we'll have Roman 1, that is solution of equations of the form dy over dx equals to f of x. And you can simply say that a differential equation of the form dy over dx is equals to f of x is solved by direct integration. So you integrate directly, e.g. we say that the solution of y equals to the integral of f of x with respect to dx. So the solution to y is equivalent to the integral of f of x with respect to dx. Let's investigate the steps to be followed, stroke to be used. The steps to be followed, stroke to be used. Step number 1, you replace y prime with dy over dx. Then step number 2, you separate x terms and y terms. You separate the x terms and the y terms. Then 3, you integrate both sides. For example, you can say the integral of, into bracket, let's leave it like that, let's put it like that, with respect to dy is equivalent to the integral of, again we leave it as a dash, with respect to dx plus the constant of integration. Now this constant of integration is actually incorporated after you've performed your integration. So we presume that this is what will give you your solution. And this is now what we refer to as number 4, the implicit form of the solution. So actually the other step is now to get the implicit form of the solution, and that implicit form of the solution is given by performing your integration on both sides. Then number 5 is what we refer to as solve. You solve for y. This one will give you an explicit solution. So let's take an example. So examples, we are going to use very simple example. So this one says determine the general solution. Determine the general solution of x dy over dx equals to 2 minus 4x cubed. Now solution to this, so we have it as x dy over x equals to 2 minus 4x cubed. So first is separating the variables, and if you divide both sides by x, this will give you dy over dx equals to 2 minus 4x cubed divided by x. and therefore this is, by simplification, this will give you dy over dx equals to 2 over x minus 4x square. From there, multiply both sides by dx, multiply both sides by d of x. So this will give you dy is equivalent to, into bracket, 2 over x minus 4x square multiplied by dx. Then integrate both sides. You integrate both sides. So the integral of dy is equivalent to the integral of 2 over x minus 4x square with respect to dx. So if you integrate dy, the integral of dy will give you y is equals to 2. So from the SMP table, we clearly know that the integral of 1 over x is simply the natural log of x. So this is, now this part alone here will give you 2 natural log of x minus, sorry, this is minus 4 over 3 x cubed. Then you include your constant of integration, constant c. So simply this is what we refer to as the general solution. Then example 2, we have dy over dx is equivalent to cos 4x minus 2x, and again solution to this, you multiply both sides by dx, and after multiplying both sides by dx, this will give you dy is equivalent to cos 4x minus 2x dx. Then you integrate both sides. So the integral of dy is equals to the integral of cos 4x minus 2x dx with respect to dx. So the integral of dy is y is equals to, the integral of cos 4x is simply sine of 4x, you divide everything by 4 minus 2x square, everything divided by 2, plus your constant of integration c. So you simplify this one, and your general solution becomes y equals to sine of 4x divided by 4 minus x square plus constant c, and that's all. Then we can have another example, just simplified examples for your understanding. We can have example number 3 here, and it say that dy over dx is equals to 1 over 1 plus x square. So solution, first multiply both sides by dx, multiply both sides by dx, so this one will give dy equals to 1 plus x square dx. So you have said this is dy equals to dy equals to 1 over 1 plus x square dx. So from there you integrate both sides, and that is to say the integral of dy is equals to the integral of 1 plus x square with respect to dx. So for the first part, the integral of dy, this gives y is equivalent to. Now there's something here that you need to recall, which is if we talk of the derivative of tan inverse of x, the derivative of tan inverse of x. So you recall that the derivative of tan inverse of x is actually 1 over 1 plus x square. So, and in our bracket here, we now supposed to reverse this. So you are supposed to reverse, that is, integrating simply means it's a reversion. So you're supposed to reverse this, and upon reversing, this is simply tan inverse of x plus your constant of integration c. Now let's have another simple example. We have another simple example. Just a minute as I think of an example. So we can say example number 4, that is 2x dy over dx is equivalent to 3 minus x cubed. 3 minus x cubed. So let's look at the solution for this. So first is you divide both sides by 2x, and this gives dy over dx equals to 3 minus x cubed. You divide by 2x. Then multiply both sides by dx. So this is dy equals to 3 minus x cubed divided by 2x dx. Then integrate both sides. So we'll have the integral of dy equals to the integral of 3 minus x cubed with respect to 2x, not divided by 2x with respect to dx. So from there, we know that the integral of dy is simply y is equals to integrating the other side this is simply equivalent to saying the integral of this is 3 divided by 2x minus x cubed divided by 2x with respect to dx. First you simplify. You can either simplify or you integrate. So something very important, we have an x on the denominator part here, and this x simply gives us the natural log. So this becomes y equals to this is 3 over 2 natural log of x minus, so if we simplify this one, this is like x squared, so it is half x squared. Upon integration, this would give you 1 over 6 x cubed plus constant c. So therefore our general solution is y is equivalent to 3 over 2 natural log of x minus 1 over 6 x cubed plus constant c of integration So let's take another example. And that is example number 5. Anyway, example number 5. And in this example number 5, we're supposed to get, in other words, determine the particular solution. You determine the particular solution So number 5 is determining the particular solution of differential equations. So number 1, that is so we have dy over dx plus x equals to 3 given y equals to 2, given y equals to 2 when x equals to 1. So solution, we have dy over dx plus x equals to 3. So therefore, first we separate the variables, so we multiply both sides. By dx, so dy plus x is equivalent to 3 of dx, and therefore we subtract x from both sides. We subtracted x from both sides, and this will give you dy equals to 3 minus x of dx. So from there, we integrate both sides. So dy is equivalent, the integral of dy is equivalent to the integral of 3 minus x with respect to dx, and this gives you y is equivalent to, if you integrate this side, this will give you 3x minus half x square plus constant c, and this is simply what we refer to as the general solution. That is our general solution. Now, for us to get our particular solution, we substitute at y equals to 2 and x equals to 1. So therefore, our particular solution is simply obtaining the value of our constant c. So we substitute the initial condition, that is y equals to 2 and x equals to 1, in this equation of the general solution. So we say y equals to 3x minus half x squared plus c. So we know y is 2 equals to 3 into 1 minus into 1 square plus c, and therefore constant C, if we make it the subject, if we make constant C the subject, if we make C the subject, this simply becomes 2 minus 3 plus half, and therefore C is equivalent to negative half. Therefore, particular solution becomes y equals to 3x minus half x square minus half. So this is our PS, that is our particular solution. Let's have example number 6. Example number 6. So example number 6 says 1 over exponential x plus 2 is equivalent to x minus 3 dy over dx given y equals to 1, when x equals to 0. So solution. So my dear viewers, I would suggest that you give it a trial. Try to find the solution, that is both the general solution. So you try and get the general solution, that is 1. Then 2, you try and get the particular, solution. So until we meet again next time, and feel free to post your answer. And particularly the value of constant C. Feel free to post the value of constant C at the comment section. Thank you. Remember to share, subscribe, like, comment, and also you can feel free to post any question in my comment section, and I will look at it. I will help you solve the question and make you understand. Thank you for your time. Please subscribe, share, and also tell a friend there is something good in this channel. Tell a friend. If you are a trainer, a teacher of mathematics in technical institution, please share the video with your students. Let them learn, let them have the concepts at their fingerprints. Thank you. Thank you. And until next time, it's a bye-bye from me. I've been your trainer and your teacher, Mr. Brian. That is my name. And I do teach mathematics. Thank you. Thank you. Have a nice day and enjoy yourself in mathematics. Thank you. Bye bye.